Open your book to page 355. We're starting a new activity today, which is activity 24, and it's called Adding and Subtracting Polynomials. But first, this lesson 24.1 is all about polynomial terminology. So we're going to be looking at a lot of vocab terms. So the first learning target is to identify parts of a polynomial and identify the degree of a polynomial. So to keep track of all of this, we are going to have a note sheet or an organizer, and it's titled a VIP, so it's a very important paper, so I don't want you to lose it. All right, a solar panel is a device that collects and converts solar energy into electricity or heat. The solar panel consists of interconnected solar cells. The panels can have differing numbers of solar cells and can come in square or rectangular shapes. So some of you might have seen solar panels in real life. If we're looking at the one below, we need to count the solar cells. So this would be 1, 2, 3, 4, and keep going till you get an answer. So this has a total of 16 cells, right? It's a 4 by 4. 4 times 4 is 16. Now, if a solar panel has 4 rows, as the picture does above, and if it has an unknown number of columns, we're going to use x, write an expression to give the number of solar cells that could be in the panel. Now, remember, an expression has no equal sign. So the number of rows, 4, times the number of columns, which is x. So 4x would be our answer here. Number 3 says, write an expression that would give the total number of cells in the panel for a solar panel having x rows and x columns. Well, just like above, I counted that this was 4 and this was also 4, and I did 4 times 4 and got 16. So what if we didn't know the number of cells? So if this, instead of being a 4, if this was an x, instead of being a 4, this was an x, we're going to multiply x times x, which is, think about our exponent rules. There's a 1 and a 1. X times x is x squared. Now, if there were 5 panels like those found in question 3, write an expression, no equal sign, to represent the total number of cells. So I have 5 of the x squareds. So 5 times x squared is 5x squared. Okay. All of the answers in questions 1 through 4 are called terms. A term is a number, a variable, or the product of a number and or variables. So this is our first vocab term that we're going to put on our organizer, our note sheet, in just a second. But question 5 says, write an expression, again, no equal sign, to represent the sum of your answers from question 1, 2, and 4. So question 1 was 16, and the sum needs to add. Question 2's answer was 4x, and then sum means to add. And question 4's answer was 5x squared. So this is still an expression because I have no equal sign. So on our note sheet, we are going to fill in what a term is. So the definition straight from your book. A term is a number, a variable, or the product of a number and or variables. So some examples, a number, so I'm going to write 5, or we could also have a negative number that happens to be a decimal, so negative 1.78. It said a variable, so I'm going to use z. Or we could have x squared. And then a product of a number and variable means that we're multiplying a number and a letter. So 3y. Or we could have negative 2w to the 5th power. Those are all examples of terms. Okay? So in your book on page 356, we are going to answer questions 6 and 7. So expressions like the answer to number 5 are called polynomials. A polynomial is a single term or the sum of two or more terms, and they have to have whole number powers, whole number exponents. So this is another vocab term, and we're going to add it on our list in just a second. But let's focus on question 6. List the terms of the polynomial that we wrote in question 5. So the first one I wrote down was a 16. The second one was 4x, and then 5x squared. So those are all terms. And together they make up a polynomial, which is the sum of two or more terms. And notice they have whole number exponents. Okay? So before we add this to our list, let's add this to our list right now. So a polynomial. It's the second one down. A polynomial, straight from the book, is a single term or the sum of two or more terms with whole number exponents. So a single term would be 10a, b, c. And even if I put an exponent here, that still works because it's a whole number. A sum of two terms would be, let's say, 2x plus 3. And then more than two terms, so let's do 3 terms. X squared plus 7x plus 6. That works. Or I could do something with 4 terms. 4x cubed minus 3x squared plus 2x minus 8. So all of these are examples of a polynomial. So the terms put together make up polynomials. Okay, back to the book, question 7. It says, what are the coefficients of the polynomial and what is the constant term? Well, those are new words for us. So a coefficient, you might have heard me use this before, is the numeric factor of a term. It's the number. Usually it occurs in front of the variable, in front of the letter. A constant term is a term that only contains a number. Okay, so it's completely by itself. Does not have a variable or a letter attached to it. So if we look up in question 6, I have two coefficients here. 5, because that's the number in this term, in front of the letter, the variable, and 4. And then the constant term is the number by itself, which happens to be 16. No variable or a letter attached to it. So back on our note sheet, we're going to add both of these. So under coefficient, you can write it's the number in front of the variable, or if we use the term the book gave us, it's the numeric factor of a term. Numeric factor of a term. So, some examples. So I want you to circle or underline the coefficients for these 3 examples. So the coefficient here is 2, -5, and 4. Okay, so circle them, box them, highlight them, whatever works best for you. Next, the constant term. It's always at the end in standard form. We don't know what standard form is yet, but we're going to learn about it. So it's always at the end in standard form. And remember, it's any term that contains only a number. So it's just a number by itself. So like -8, 7, 11, -5.6, etc. Any number by itself. All right. Question 8. Tell whether the expression is a polynomial and explain your reasoning. So I want you to look at A through D. Remember, the only condition is that it has to have whole number exponents. And think about our exponent rules. We cannot have negatives. So try these questions. 8A, the answer here is no. Why? Because there's a negative exponent. Right there. From our exponent rules, we can't have that. Letter B, yes, there's positive, they're whole numbers. Letter C, yes, even though it's a single number by itself, we still call this a polynomial. It's a constant term. Letter D would be no because of the fraction. Okay? For the expressions in question 8 that are polynomials, so letter B and C, identify the terms, the coefficients, and the constant terms. Okay? So I'm going to kind of organize my work here. So here's B, here's C. We're going to identify the terms, then the coefficients, and and the constant term. I'll just rewrite it. So go ahead and answer questions B and C. Use your note sheet to help you if you need it. So in letter B, we have two terms. We have 6x and we have 4x squared. Coefficients, remember, are numbers in front of variables or the numeric factor of the term. So that would be 6 and 4. And then a constant term is a number by itself without a variable, which is not applicable in this case because we do not have a constant term. 8c, our term is 15. Do we have a coefficient, a number in front of a letter? Nope. So again, this doesn't apply. There are no coefficients. And then the constant term is the number by itself, which happens to be 15. Any questions so far? The degree of a term is the sum of the exponents of the variables contained in the term. So question 10 says identify the degree and the coefficient of each term in this polynomial right here. So the first term is listed for you. It's 4x to the fifth power. We would add the exponents, but I only have one exponent there, and it's 5, so that's the degree. So this is my degree. And then remember, my coefficient is the number, so the coefficient in this case would be 4. All right, try the next one. What's the degree? Also the exponents, or the sum of the exponent. And the coefficient is the number. See if you can fill in the rest of this table. Degree is 3. Degree, exponent here is 2. And what's the number out in front? What do we write if it's not there? We write a 1. So the coefficient here is 1. Negative x, do we have an exponent? If it's not there, it's a 1. Do I have a number out in front? Negative 1. Okay, so here's what we're going to do. We're going to add this to our note sheet. So if something is called a monomial, that means it has one term. And this is in your book for you on page 357. But I think it's important that we address this now. So if it has one term, it's a monomial. And let's go through some examples here. 7, or I could have something that looks like 5x, or I could have negative 4x squared. A binomial has two terms. So x minus 3 or 2y squared minus 6y. So think of a tricycle or a triangle. 3 terms. So x squared plus 11x plus 10. And then after that, we don't have any specific names. So a polynomial is just 4 or more. So if I give you an example of that, let's do 9x to the 4th power plus 2x cubed minus x squared plus 5x minus 4. So that has 5 terms. I call it a polynomial. 3 terms, trinomial. 2 terms, binomial. All right. Uh-oh, where did question 11 go? So for question 11, we had this really long polynomial starting with 2x cubed y, and it ends with a 15. So if you don't have enough room in your book, you can use the My Notes section if you need to. This is on the bottom of page 356. We are going to write down each term, because that's what it says to do first. List each term. Here's my first term. Here's my second term. Keep going. And then it says identify the degree, which that's the sum of the exponents. And we're also identifying our coefficient. Okay, so I'm going to abbreviate using D for degree and C for coefficient, so it's less writing for all of us. So let's add up these exponents here. It's 3 plus 1, so my degree is 4. The coefficient is the number out in front, so that's 2. All right, keep going. Pause the video, and I want you to try to finish all of these. So the degree here, 2 plus 2 is 4. Coefficient out in front, -6. Degree, our exponents, 1 plus 1, we get 2. Coefficient out in front, 9. Degree here is 5. Number in front, 13. Oh, I forgot about my sign, which you might have too, because it was on 2 different lines. So this negative goes with that 13y. That is totally my fault. So the coefficient is -13. Degree here is 1. Coefficient is 5. And then I'm going to erase this and just write constant term. So the last one, it doesn't really have a degree, it doesn't really have a coefficient. We're just going to say that 15 is the constant term. All right.